second session for module 3 embedded system components. So last class, some introduction part, what are the content we are going to discuss, and definition of embedded system, then the general block representation of the embedded systems, and comparison between general computing system and embedded system. These are the things covered in the last class. So now today's I'll going to discuss about the classification of embedded system. How embedded systems are classified. The embedded systems are classified based on generation, like first generation, second generation, like that, and based on the complexity and performance requirement in the embedded systems. And third one, it is deterministic behaviors, and fourth one is based on triggering. These are the four classification based on different parameters. Now I'll go to one by one. First I'll start with based on generation. Is nothing but based on the literature survey. From 4-bit controller to the 32-bit controllers, and how embedded system support for that. So this is the first one. It is classification based on generation. Is it visible all of you? Please respond.
Yes, sir.
Yes, sir.
Yes, sir. Visible.
Yeah. Here, this based on this generation, mainly we have four classifications. So the four classification is nothing but the first one is first generation, second generation, third generation, and fourth generation. In the first generation, started with 8-bit microprocessor like 8085 microprocessor, and one more very popular microprocessor, that is Z80. During 1980s and 1990s, the decades, these two microprocessors are very popular in the market. One is Intel process, that is nothing but 8085 microprocessor. It is a 8-bit. And another one, it is Zlog process, that is nothing but Z80. It is also the 8-bit microprocessor. During this first generation, they considered 8-bit microprocessors along with 4-bit microcontrollers. So clearly it indicates that 8-bit microprocessors and 4-bit microcontrollers. 4004 introduced during the time, during the first generation, that is what? 4-bit microcontrollers. But during that time, only their utilized microprocessor, these Z80 and 8085 processors are there very popular in the market to use all kinds of toys and all these things. The real-time applications they use for that, because 8085 is a very popular microprocessor. It is one of the very fundamental microprocessors. Now in your syllabus, they removed 8-bit microprocessors. They introduced directly 16-bit microprocessor, that is called as 8086. And even nowadays, the all microprocessor will be removed, only directly introduced microcontrollers, because the technology they're looking towards to that 32-bit microcontrollers. That is what they're concentrating only about to that microcontrollers part. They're not worrying about the microprocessors. So during this first generation, do these two things. You have to remember, one is called as 8-bit microprocessor, second one it is called as a 4-bit microcontrollers. And after the first generation, second generation. See here in the second generation, they introduced the embedded system 16-bit microprocessor, and mainly they're concentrating on 8-bit microcontrollers. And it follows the first generation embedded systems. In the second generation, they introduced 16-bit microprocessors and 8-bit microcontrollers. Even some small 32-bit controller also introduced, but the mainly in the market they introduce only 16-bit microprocessor, then 8-bit microcontrollers. That is what in the second generations. Now we'll come to the third generation. During this third generation, embedded system built around high performance 16 or 32-bit microprocessors or microcontrollers, mean that we can use the concept from first generation and second generation, both 8-bit or 16-bit and 32-bit microcontrollers, or it may be microprocessors, along with some of the very specific concepts introduced during this generation, that is called as application specific instruction set process, like digital signal processing DSPs and ASCIIs, application specific integrated circuits. It was introduced during the third generations. Even in the latest technology, still they are very familiar, and in the real-time applications, day-to-day activities, still we are using these devices or these embedded systems. It is nothing but the very specific device or system. Get my point? So that is what will be called as the DSP, application specific instruction set. All these things will be introduced during the third generations. Now we'll come to that. The last generation, it is called as a fourth generation. During the fourth generation, embedded systems built around system on chip SoCs, and reconfigurable process and multi-core process. Now almost all laptops, it's available in the multi-core process or multi-core process platform. So that is why people now we are using in the fourth generation of the embedded systems. So this is what the major classification. First generation, second generation, third generation, and fourth generation, they belongs to the generation classifications. Now I'll go to the next generation. It is called as classification based on complex and performance. So second classification based on complexity and performance. So here for this complexity and performance based sub classifications, we have three types: small scale, medium scale, and large scale. In the small scales, it's like in the early embedded systems built by using microprocessor like 8-bit microprocessor, what I told in the last slide, 8085 microprocessors, and another microprocessor, it is a Z8. These are all belongs to comes under the small scale integrated circuits or in the embedded systems. And along with that, 4-bit microcontrollers also using during this complexity. The complexity is nothing but small scale complexity. And then comes to that medium scale. The next sub classifications from the complexity and performance. These embedded systems are built by using 16-bit microprocessors and 8 or 16-bit microcontrollers also using, and it follows from the first generation embedded system. That is what they introduced during these, or we can build the microcontrollers in this medium scale. And the lastly, another sub classification that is based on the complexity and performance. It is very specific embedded systems. What they introduced in the third generation or fourth generation from the previous classifications. The same complexity we are using here. Example, DSPs, application specific integrated circuits, and very specific related devices. They are developed during these large scale or complex. Till today, we are using these large complex embedded systems. Along with that, what do you mean by complex? Can use high performance microcontrollers or microprocessors or some of the specific systems built into a single chip and to streamline the communication. That is what the complexity of the embedded system. So based on these classification is based on the complexity and their performance. So I'll come to that. Another classification, another last two classifications are there. One is called as classification based on the deterministic behaviors, and another one classification based on the triggering. Within this slide only, I'm going to discuss about these two. First, I'll come, I'll going to discuss, sorry, explain about that deterministic behavior. So what do you mean by deterministic behaviors? But this deterministic behavior is applicable only in case of real-time systems. Many real-time systems are product we are using nowadays. These deterministic behaviors is applicable for real-time systems. So in the real-time system, the mainly we are worrying about to that execution behaviors, where we are going to execute the programs, how they are responding. When during we are explanation, we are asking the questions how the students are responding. That is what the real time. The real time is nothing but the responding at an instant. It is called as real time. Responding at an instant, it is called a real time. If you don't know the definition, please take down. This is very important. Another, these three modules we are using real time. That is a one common word we are using. In the textbook also, in our notes also, in our class also, we are using these technical terms. What you mean by real time? Real time is nothing but responding at an instant. So nowadays in the day-to-day activities, some of the embedded systems we are using in the real time, By the time we are going to find out that deterministic behaviors. In the deterministic behavior, we are looking about to that execution behaviors. Execution behavior is nothing but during the execution time, or another name it's called as during runtime. So these execution behavior for the embedded system can be either, we can decide it, either it may be a deterministic or it may be a non-deterministic. If it is deterministic, then only you have to go for a real-time system. If it is not deterministic, no, it's not support for real-time system. That is what the indications we are going to use. Either the system is deterministic or maybe non-deterministic. If it is the any system of an embedded system, it is a deterministic, we can use for real-time system. If it is non-deterministic, we are not going to use in the real-time system. That is what we are going to decide it. And the next, during the executions behavior, if it is deterministic, if used in the real-time systems, we have two classification. One is called as a hard and other one is a soft real-time systems. Regarding these hard real-time system and soft real-time system, I was explained in the previous class with some few suitable examples. I hope that I remember with these examples. Yesterday we discussed with some examples and clarified with even from your response also. I think yesterday Nitin T is responded related to these and Naveen also responded during these examples. I think I hope that you are remember all these things. In the odd real-time system is nothing but flight system. What example I told yesterday? Anybody's? Pranesh B. Or remember it? What example I taken for odd real-time system? Pranesh B. Are you there in the class?
Yes, sir.
What example I consider Pranesh?
Sir, I was not there in class yesterday. Last week.
Hey, yesterday not attended the class.
No.
Pranesh, why? Next, anybody's please answer for this at least. Rahul Reddy, are you there? Rahul Reddy.
Sir, flight mechanisms for real time.
Yeah, flight mechanism. So Pawan Kumar, no?
Yes, sir.
Yeah, flight mechanism. During the time I explained that wheel and wing operations. Is it correct?
Yes,
Wheel and wing operations. So how wheels and wings operated. So that is what one real-time or real-time embedded system. So I explained with in details last class, but none of them they're not turned off. Have any difficulties following my class?
no, sir.
Hmm? ಆನ್ಸರ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಏನ್ ಅನ್ಕೋಬೇಕ್ರಿ ಪವನ್ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ ಅನ್ಕೋಬೇಕು am I right?
Yes, sir.
ಅಲ್ವಾ
ಹೌದು sir.
Okay, fine. So that is what we considered in the odd real-time systems. Nitin is there in the class? Yesterday I think Nitin also responded related to this. ಅಲ್ಲೇನೋ ನಿತಿನ್
ಹೇಳಿ ಸರ್.
ಏನ್ ಕ್ವಶನ್ ಮುಗ್ದ್ಮೇಲೆ ಹೇಳಿ ಸರ್ ಅಂತೀಯಲ್ಲ ನಿತಿನ್?
ಎಸ್ ಸರ್ ಅಂದೆ ಸರ್
ಎಸ್
ಫಸ್ಟ್.
ಸರ್ ಅಂತ್ಯಾ? ಓಕೆಪ್ಪ ಗುಡ್. ಓಕೆ ಫೈನ್. And here other thing, other one it is called as a soft real-time system. I think almost all other than these hard real-time system, they comes under the soft real-time system. They are not fixed boundaries. It may be plus or minus. Before or after you have to be completed. That is what the soft real-time systems. So if the real-time system it is in the deterministic, then you go for either in the hard real-time system or it may be in the soft real-time systems. And now I'll come to that reactive in natures. There is reactive in natures can be classified based on the triggering. So in the last classification based on the triggering, it comes with triggering. Either it may be a event triggering or time triggering. That event triggering and time triggering, that it will be derived from that in the reactive in natures. Can be classified based on the triggering. The last one. The classification based on the triggering. So that is also very important. Event triggering means work commitment. You have to complete the work. But time triggering is not like that. It is only the time dependent. Only so punch in, punch out time only considered. We are not considered with respect to work. But always in the real time system, we looking with both event triggering and time triggering. But some manual applications or some of the concept in the static, they are worrying about only with respect to that event triggering or time triggering. Either we can work within these boundaries, either we have to work within these event. The work have to be completed. Now, with respect to these, due to the pandemic, from last 1 year, almost 1 year, 3 months, from last March, the IT people's working from home. Before, during the lockdown, they work from morning 9 to 6 or 9 to 7. That is what bounded time. But due to the pandemic, the permission is allowed work from home. So sometimes they attended up to 8:30, 9, 9:30 also. It will be extended. The time is extended. And as per the survey, some of the software industries, they release a statement, even though work from home, they have more work extract from the employees instead of offline. In the online work from home, they are utilizing more resource because their involvement from morning to evening involved in the project. Anytime can arrange a meeting, can discuss at any moment. It is possible. But during the offline only, you have to plan the meetings. All are available, then only you can conduct the meeting. Now it will be little bit changed. The scenario it will be changed. It will goes to the other directions. Even in the classes also, we are not planned before the lockdown, before the pandemic. We are not think about these online classes, how it is conducting all these things. So now everything it will become streamlined. In the first lockdown period, some of them struggle to teach even online also. Faculties also struggled during the time because of they have some problems. Maybe electronics gadgets, maybe internet, or maybe they don't know how to use in the online, how to interact in the online. They face a lot of problems. But during the second lockdown, I think almost more than 50 to 60% of the problem is solved. Now during this period, the classes is going smoothly compared to that first lockdown period. Even the students also, they are very familiarly involved. Even now schools, primary schools also adopted this kind of teaching. They are enjoying. Okay. Means that here will come to that two things. One is either you are from the office or you are from the home, you have to complete the work. That is called as event triggering, work bounded. But once comes to that embedded real-time systems, we can consider both time triggering along with that event triggering. Both parameters is very essential and is required. If you are any one parameters not considered, we are not fulfill the real-time system. Not only in the real-time system, example in any embedded system. We can take example washing machine. Based on the class or the type of the class, we can put that, we can select the options from either 15 minutes to the 1 hour like that. So it means that there even it may not real-time system, even though we considered both event and time. The time is 15 minutes. Within that, that complete their specified task. The specified task means depends. If it is 1 hour, even though 1 hour also, they complete their task. That is what will be called as a embedded system as a specific functions, the defined functions. But some other devices they are not set the particular goals, but all embedded system the goal is set. Microwave oven only you to set the temperatures. It may be grilled or it may be a non-grilled. If it is required very low temperatures, you can go for grilled. Sorry, non-grilled or grilled. We have two types. Their temperature levels or capacity of the temperatures. Then fridge. It is also specific functions. Different are the liters. How many liters? That decided that range. How much that cooling capacity is there. Everything it will be decided by. It is specific. So that is what almost more than 90% of the systems or embedded system they are worrying only about both event triggering and time triggering. This is what the classification of embedded systems. So any doubts from these classifications, please raise your questions. Once again, just I conclude that what you mean by or what are the types of embedded system. Mainly embedded systems are classified based on 4 parameters to be considered. In the 4 areas you have to be considered. One is respect to the generation, first generation, second generation, third generation, and fourth generations. Second one with respect to the complexity and performance, small scale, medium scale, large or complex. That is what the sub classifications from complex and performance requirement of an embedded systems. And then third classification comes to the deterministic behaviors. Any real-time system, it will become deterministic. We can use for real-time systems. Either during the time, it may be a deterministic or it may be a non-deterministic. If it is deterministic, you can go for real-time system. If it is in the real-time system, may use soft real-time system or it may be hard real-time systems. And the last one, it is based on triggering. Based on triggering means either with respect to the event triggering or it may be a time triggering. With respect to the time commitment or maybe with respect to the work commitment. Maybe. But in the real-time system, we are going to consider both work commitment along with the time commitment also. You have to complete the specified work with specified duration of time. That is what the real-time system. Are you clear now? I hope that all of you clear now what you mean by real-time system. The real-time system is nothing but they are going to complete their specified work as well as the specified time. The work has to be completed within the boundary with specified limited period of time. That is what the real-time system. This is what the classification of embedded system. So in the examination, usually they are asking about that 6 marks questions. During the time, please all of you at least